welcome back. Here is Ali Talabi, and this is lesson 6 from module 20. In this session, as I promised, I'm going to talk about Black and Scholes option pricing model. So let's talk about this approach. So when we talk about the binomial model, I mentioned that there are many limitations to binomial model. I mentioned that we just assume two possible scenarios, but we know in reality the possible scenarios for the stock price is much more than two options. So it's better to use a kind of approach which has fewer limitations. So Black and Scholes, that's the model that is mainly used in the world of finance. This approach is actually created by professors Fisher Black and Myron Schultz, or Myron Schultz in 1970s, and it is used to find a call option price before maturity, the value of the call option before maturity. And unlike the put call parity, unlike the binomial model, we are not using the put price to find the call price or the opposite way. We don't need any information for the put to find the value of the call price. However, remember one major limitation here is that you can use the Black-Scholes model to find the European style option. So those options which you can exercise right at expiry date. And for sure, another big limitation or assumption is that there is no dividend payment. So you can just apply this approach to European options, which they pay no dividends. So for sure, again, this model has its own limitation, but for sure it's much more accurate and less limited than the binomial approach. So let's talk about this model more. According to Black-Scholes model, there are 5 major variables or factors which determine the option price. What are these factors? The stock price for sure is one of those. We use S for that. K is the exercise or strike price. The interest rate, the risk-free interest rate, or R, the time remaining until the expiry date, which we use T for that. And finally, the volatility of the underlying asset, which here is the stock. We use sigma to show the price volatility of the stock. Now, how actually the formula works? So let's talk about the formula in the next part. So to find the value of the call option, we are using this formula. You see SND1 minus K e to power of minus RT ND2. And to find the put option price, we are using this formula. See KE minus RT N minus D2 minus SN minus D1. Now, I have to break it down to the components to be able to actually find the option price. The first step here is to find the D1 and the D2. So what are those? Maybe you know about S, maybe you know about R or T, but what are these D1 and D2? So we use these formulas, as you see here, to find the D1 and D2. D1 is simply based on the natural logarithm of the stock price and the exercise price, and plus R plus sigma 2 divided by 2 times by T, and the whole part you should divide by sigma times square root of T. So we have all the components. You know the S, you know the K, you know the sigma and R and T. Simply you can find the D1. Now, when you find D1, based on that, you can calculate the D2, which is simply D1 minus sigma square root of T. I'm going to talk more about D1 and D2 and the Black-Scholes formula in the following part. Now, let's talk about the components of the call option and the put option. What is the e to power of minus RT? So that's exponential of minus RT. It's much better to use a financial calculator or those calculators which are equipped to the e to power of x function, or you can use simply the Excel file to find the exponential of minus RT. And as you see, that's a natural exponent of the value of minus RT, which is actually your discount factor. So we talk about the R, risk-free rate, and we talk about T, the time to expiry date. So that's technically your discount factor. What is the ln s over k? That's your natural logarithm of the moneyness term. So what is the moneyness? We already talked about the in the money, out of the money, at the money. So when you compare the exercise price with the strike price, we talk about three possible scenarios which might happen for both call option and put option. Please go back to lesson 4 when we talk about these terminologies. What is ND1 and ND2? Here we are referring to a standard normal probability for the values of D1 and D2. To find the ND1 and ND2, again, either you can use the Excel file, or there are some online platforms, web pages, which you can find the normal probability of these numbers. Later, I will talk about this, how you can use Excel file to actually calculate ND1 and ND2. In the formula, if you notice in one of the formulas, we talk about N minus D1. And remember, N minus D1 is equivalent to 1 minus ND1. So instead of N minus D1, it's much easier to use 1 minus ND1, just to make it clear as a reminder. So let's look at an example. So enough of talking about the formula and D1, D2. Now let's talk about the example and see how we can actually apply the Black-Scholes model to a specific case. Let's assume you're talking about this stock, which has the price of 50 bucks. And the exercise or strike price is 45 bucks, and you have 3 months until expiry. You have to be careful because the T is expressed on annual basis. So if, for example, your T, like this example, is 3 months, so you are talking about 0.25. So your T is 0.25. If, for example, it was 6 months, what is your T? Yeah, yes, you're right. The T should be 0.5. So, or half a year. And sigma is standard deviation, which you use to measure the volatility, is 25% or 0.25, and the risk-free rate is 6%. Now, you have all the inputs. Based on this, you can calculate the value of your option. As I mentioned, the first step here is to find D1 and D2. So we already have the formula for D1. Just plug the numbers. You need to have the calculator or Excel or some online web pages to find the natural logarithm. So that's the ln of 50 over 45, and the rest are just plug the numbers. Now, I just found the D1 as 1.02538, and I can use the formula to find the D2. Now, we have both D1, this is your D1, and D2. Now, it's the time just to talk about the next part, which is the probability, the normal probability of these numbers, D1, ND1, and ND2. Now, as I promised, the best way, or the best or the easiest approach to find the normal distribution here is use the function which you can find in Excel. So in Excel, the function is easy. It's norm.s.dist. And we already calculated the D1. So based on this, you can find the ND1 and ND2 if you need. For example, here you see that, so this was your D1 and this one was your D2. So what is that, true or false? The true is talking about the cumulative, the false is non-cumulative. You should choose that true portion, which is showing the cumulative of the normal distribution. As a reminder, maybe from your high school or from your undergrad, you remember that normal distribution. So here it's showing that what is the probability, or what is the coverage of that 1.0253 D1. So that's 84% or 0.84. So you can use that function here just to find the ND1 and ND2. And here we are not just looking for the ND1, we also need to have N minus D1. And I just mentioned the N minus D1 is 1 minus ND1. So since we just calculated the N D1, you just plug the numbers, so it should be 1 minus 0.84 as we just got from here, and 1 minus 0.81 we just got from here. Now we have all the requirements just to calculate the option price. So we just found ND1, ND2, N minus D1, N minus D2. So we can find the call price and the put price just by plugging the number. So in our case, as you see, the call price is $6, 1.95, and the put price is 52.5 cents. So simply by plugging the numbers, you just calculate the call price and the put price. Again, just the only point here is when you plug the numbers, just make sure you follow the priority in terms of the functions, multiplication or division, then plus or minus, and make sure that you are using the Excel file when it comes to normal distribution. Now, let's talk more about the implication of the changes on those 5 major factors which we discussed on the option price. So I listed all those 5 factors here, just showing you what's the impact of the changes in these factors on the option price. Now, we have call option, we have the put option. You see, some of these factors, they have the same impact on the call and put option. For example, if you look at the time remaining until expiry date and volatility, you see both they have positive impact on the put option and call option. So regardless of the type of option you have, if the time remaining till expiry is going up, you should pay higher premium for the option. And you can check that if you go to the Yahoo Finance, for example, and check the option for a specific company, you will see for the longer period options, you have to pay higher premium. We had this example before for the Microsoft. I just explained why you have to pay a huge premium for a specific stock which has a higher time or longer time to expiry. The same for volatility. As the stock or the underlying asset, in this case, which is a stock, is more volatile, the standard deviation is higher, also you have to pay higher money for the option, higher price for the option. Why? Because actually option is used to hedge yourself. It's protecting you from fluctuation. But for 3 other factors, depending on the situation, it might have positive or negative impact. For example, for the underlying stock price, as the stock price is going up, the value of the call option is going up because the call option gives you the right to buy the underlying asset. So higher stock price, it means still you can buy at the lower price, which was your exercise price. So that's why the call price is worth more. What about the put option? For the same reason, the put option worth less because the put option gives you the right to sell the option. Now, if the stock is going up, there is a higher chance that you have to sell at the lower price, which is your exercise price. That's why the put option worth less. You can go for the similar argument when it comes to exercise or strike price, but you know it works on opposite direction. You know the higher strike price leads to the lower call price, and the higher strike price leads to the higher put price. What about the last portion, risk-free rate? Now, I provided a note here regarding risk-free interest rate. As you see, because I've seen many students kind of get confused when it comes to the risk-free interest rate. Remember, the interest rate reduces the present value of the future price, which in our case is the strike or exercise price, and therefore increases the current price. That's why you see for the call option, the risk-free rate has a positive impact, and for the put option, the risk-free rate has a negative impact. As the risk-free rate is going up, it means that the value of the strike price is going lower. So you can compare this actually with the strike price, and you see that's in opposite direction because the value of the strike price, it becomes less, which means that actually the value of the call option becomes more when it comes to risk-free rate. And finally, before wrapping up, just let's remind you something from delta. We already talked about the delta, and I mentioned that when we were talking about the binomial model, I mentioned that I'm going to talk more about delta. Now that's the time. Delta, that's a fraction of the share which you added to your portfolio. To be more specific, the delta is measuring the dollar impact of the changes in the underlying stock price on the value of the stock option. In other words, you want to see if the stock price is changing, what is the impact of these changes on the value of the option. So how you can measure that? By using ND1 and N minus N minus D1 when it comes to put option. So remember, for the call option, the delta is ND1, which you should expect a positive one. And for the put option, the delta should be negative because you know that as the stock price is going up, the value of the call option becomes more. as the price is going up, the value of the put option becomes less. That's why for the put option, the delta is negative. Again, it shows the $1 change in the stock price. Uh, it shows that when the stock price is changing by $1, the option value is changing by delta dollars. Now, again, how you calculate delta? You can use this formula to find the delta. That's it for today. Thank you very much. Have a wonderful day. Talk to you soon. And here is Ali Talabi.